Hello, guys. Hello.
Yes, sir.
Hello.
Vedic, you can start.
Okay. Whatever the mind can conceive. Hello. Hello.
Yes. Can we start or? ايش فتنا؟
Nishit, can you hear me?
Yes, yes, you can start.
Okay. Whatever the mind can conceive and believe it can achieve. A very good evening to all of you. I am Vedic Chaudhary, and on behalf of IADC PDEU Student Chapter, I welcome you all to this webinar on gas well drilling by Mr. Mareb Ammari. Before beginning, I would like to request all the attendees to maintain the required etiquette in order to avoid tampering the flow of webinar. Your doubts would be addressed during the question and answer session towards the end of the event. Now, allow me to introduce all to our today's speaker, Mr. Mareb Al-Ammari. He pursued his bachelor's degree in geophysics and petrophysics from Sana University in Yemen. He worked as a senior mud logger and data engineer in total exploration and production in Yemen Republic. He has also worked as total exploration and production well site geologist and Petro-Messila reservoir geologist. Then he pursued his master's degree in petroleum technology from Pune University, where he was the gold medalist. Currently, he is pursuing his Ph.D. from Pandit Deendayal Energy University. Now, I would like to invite him to take over and proceed the webinar. Sir, you can continue.
Yes. First of all, good afternoon, guys. It's my pleasure, to do this. It is an actually training course. I did this training course with the Total when I was there working with them. Thank you for introducing me. Just only, as you said, this is just only a short description about who. Let me introduce myself. That's my name. Also, I have good work experience with the Total. I work as a mud logger and data engineer. Work as a well site, petrophysics engineer, and reservoir geologist. This is my our current position. Guys, now we can start our overview. We are going to discuss the gas from introduction. What's the gas mean? Why do we measure gas while drilling? And what's the gas system component, type of gas while drilling, and how can we use this gas collection data and interpret them to get more information about the formation properties. The first thing, introduction. What are hydrocarbon gas and gas liquid? As we know, natural gas and crude oil are mixture of different hydrocarbon. Hydrocarbon are molecules of carbon and hydrogen in fluorous combination. There is two types of gas. There is three types of gas. There is a wet gas, dry gas, and hydrocarbon gas liquid. They call it condensation or retrograded gas. Condensation or hydrocarbon gas liquid is a hydrocarbon that occurs as a gas is at atmospheric pressure and is a liquid under the high pressure. As you see here, this table is present the gas component that the chromatograph or gas system equipment measure them. Methane, ethane, propane, butane, isobutane, normal butane, isobentane, normal bentane. And the second column is the number of carbon atoms. The third column is the chemical formulas. What we care about in this table, it's about the boiling point, because we are going to use this boiling point to distinguish or separate it between the gas component while measuring. The second thing, just only to differentiate between wet gas and dissolved and retrograded gas, we will use this chart, pressure against temperature. As we see, condensate or retrograded gas is a mixture of light hydrocarbon. What will be happen that will be happen as a pressure is reduced in condensating gas reservoir, the fluid will be past the dew point. See here, this is a critical point. This is a purple point. This is a dew point. When it's past the dew point, it will go to the liquid envelope. The fluid will pass through the dew point, and large volume of liquid will be condensed in the reservoir. At the same behavior will be at the separator or at the surface. The second one is the wet gas. Wet gas in reservoir, it will be gases, but at the separator condition, some liquid will be condensed in the separator. Because why? In a in retrograded gas, we have a light. There is a more or extremely more. There is a fewer of heavy component. While in wet gas, there is a significant heavy hydrocarbon or component. The second thing is how does gas fluid. As we know, there is 3 sources for gas while drilling. The first source is a gas bearing formation. Gas bearing formation, that's mean when the drilling bit drill that part from the hole, there will be a gas inside the porous formation. That's when we drill that part, these gases will be removed or released or getting it or feeding into the drilling fluid. The second thing is a formation feeding gas into the mud. This is happened just only when the formation pressure is higher than hydrostatic pressure. As we know, guys, the hydrostatic pressure is 0.052 multiply rho of mud density multiply depth. When the formation pressure higher than hydrostatic pressure, gas from the formation will be in flux or feeding into the drilling fluid. The third one, the source for the gases, the third source is a contamination. As we added some additive in the mud during mixing mud, or add some new mud like calcium carbonate, like caustic soda. Those materials is chemical. They will reacting with each other, or they will produce gas. So we have three sources for gas. Gas bearing formation, that gas will drill during the drilling new formation, and formation feeding gas that will be due to the pressure differential between the formation and hydrostatic, and contamination gas that will be produced from the contaminated during mud mixing or during the mud reaction with the formation, or during the mud reaction with the drill string. So this is what's the main who plays this is the important roles is a pressure differential between the formation and hydrostatic. So the second thing, now we're talking about definition of gas, the source of gas information that enters the drilling fluid. The third part is the gas system component. When formation released from the cutting into the mud stream and entered probably in solution, the drilling fluid at the surface, it is necessary to remove and detect this hydrocarbon. To do this, so we have a three parts now. Now we will have a three parts from gas component. The first part is a gas trap, and we are going to talk about it in details. What's the gas trap? How does the gas trap work? The second thing is the equipment to transport and filtration. The third one, and this is the very important thing, is a gas detector, or we call it the chromatograph. We'll talk how the chromatograph works, how many types of chromatograph do we have, and so on. Now, gas trap, I will show you. This is the just only a picture to demonstrate the two types of gas trap. The gas trap, there is two types of gas trap. There is air one in the left side, this side. This is gas trap work with the air, or air gas trap. And the right side is the electrical gas trap. In actual sense, now most of the logging unit using the electrical gas trap because it's more efficiency. How does the gas trap work? If you focus in this part, in the left side of the slice, there will be three axes like this in the gas trap. Then there is a motor. It's worked by air or worked by electric. It will rotate this axis. While rotating this axis, mud will enter from the bottom of the gas trap and relieve from noise like this in the gas trap. The motor will be rotate with the high RPM, high revolution per minute. Then if we see to this slides, you will see this is the circle of the gas measurement. The gas bubbles will be trapped, traps in the mud fluid. The cutting and the gas bubble will transfer from the bottom of the power hole and going through the POP, or blowout preventation, to the flow line. And there is this part in Shishikar, they call it busampli. Inside this busampli, this equipment, it will be there. This is the gas trap, and the gas trap is going just only to mix or wax. Just it's like do you know electrical mixer? It's like this. Just it's going to mix or wax the drilling fluid to release the gas, and the gas will be sucked by using suction pump to the unit during the gas line. This is the first part of our gas component. So continuously sample the drilling fluid and simultaneously remove gas from the fluid. The second part, it will be the transport equipment and filtration. Transport equipment is just only like a suction pump. Is a suction pump. This suction pump, it will be controlled from the mud logging. That suction pump, the main thing for it, just only to suck the gas, because there will be distance between the mud logging and the gas trap. This distance is around 30 meters, 30 meters. So the suction pump, it's going to the released gas by the degasser will be transported to the inside the chromatograph by using this suction pump. Also, there is a many filters, because we try to avoid enter any water fibers to inside chromatograph, because it's going to break down. The third thing is a gas detector or chromatograph. Gas detector or chromatograph, if you see for this slide, this is just only demonstrate for the gas chromatograph. And in this slide, there is another many types of the chromatography. There is FID, flame ionization chromatograph, fast flame ionization chromatograph, and dual flame ionization chromatograph. What's the gas chromatograph? There are two types from chromatograph. The first type is catalytic detector, and the second one is a flame ionization detector. In actual sense, most of the mad logging company now they use flame ionization detector because it's more accurate and more sensitive to the gas sample. So each of those two detectors separate and recorded the gas in the similar manner. The difference between the two is the way which the various gases are detected once separation has occurred. The chromatograph, we remember, we're talking about a boiling point in the first slide. This is boiling point. Whereas we see the methane has a boiling point minus 126. Whereas normal pentane has boiling point 36. Now, how is the chromatograph does work? Now, the chromatograph column is just only a column. Will be separated the gases in order or depend on the boiling point. The one with the lowest boiling point, methane has the lower boiling point. Will remove faster and will be analyzes more. The first thing, the general corresponding to, also this general correspond to molecular weight. So smaller molecular weight, lowest boiling point will remove faster through the chromatograph column. As well, the highest boiling point with the higher molecular weight will remove slower through the chromatograph column. This is the main principle for the chromatograph or the gas detector works. Also, the main work principle, this is what we're talking about. It's about the boiling point and the molecular weight. So the lighter hydrocarbon pass through the column first, followed by the heavier molecular or heavier hydrocarbon. So during recording, this is just only, if you see for this slide, this is just only a demonstration how the chromatograph works technically. During recording in the software, you will get some bits like this. The first bits will be arrived, it will be C1. The last bits, it will normal C5. In software, we have to calibrate the gas system chromatograph. How we calibrated the gas chromatograph, there will be a bottle, and that bottle has a fixed concentration from C1 to C5, and we will see the voltage that we're getting from the chromatograph and make a calibration for it. Now, as we mentioned, we defined the gas system. We talk about the gas detector and chromatograph or gas component. We also make small introduction how the gas enters to the drilling fluid. The second part, what types of gas while drilling. So those gas, what are they meaning for us? What the type of gas we are measuring while drilling? The first thing is the total gas reading. Total gas reading is the maximum reading during a specific interval. During a specific interval, maximum reading, it is just only, you know what, that the maximum that will be read by chromatograph while drilling. Second thing, a background gas. Background gas or is spontaneously drilling that will represent the average gas reading while drilling in low permeable zones such as shale. For example, if we have two reservoirs, if we have reservoir of sand and the caprock or the caprock is shell, so what? If we read the gas, if we take the gas reading in front of the shell formation or layer, that will be a background gas. And when we enter to the reservoir, what will be happen? The gas chromatograph will be increasing. The maximum reading that gas chromatograph will reading it will be the total gas reading. We have two types of gas connection. There are four. The third ones, and also this is the more important ones, is the connection gas reading. As we know in drilling, what does it mean connection? See, we will drill with the for the whole stand. After we finish that stand, we will pick up top drive and we remove the release the top drive to pick up new stand to connect it and resume drilling. Now, during this period is maximum 5 minutes. During this 5 minutes, during the connection between previous stand and or stand inside the hole, power hole and the new stand or new connection pipe, if the hydrostatic pressure less than formation pressure, what will be happen? As we said before, formation will start feeding or influx the gas fluid to inside power hole. So this is a bad indicator for well stability. That's mean if we have a gas connection while drilling, this is indicator or sign for kick or flow out or blowout. So if we ask ourselves why during drilling we didn't get that too much of gas, meanwhile during the connection we get a lot of gas. Yes, because while drilling we are deal with the something called ECD, equivalent circulation density. It is the hydrostatic pressure plus the annular pressure or plus the pumping pressure. So sure, the pressure while drilling it will be more than pressure during correction when the pump shut down or pump stop, where there is no pumping. The same thing is a trip gas reading, but trip gas reading it will take more time to get it, because if the bit pulling or the bit life, we need to change the bit. We have to pull out the drill string from the hole, and we have to change that bit. And when we be getting back again to the hole, start drilling and resume bottoms up or resume circulation, we will get trip gas. Also, this is an indicator for the formation pressure less than hydrostatic. So we have to inform the drilling company or the company man, take care, just increase your mud weight. Try to find out solution. Our formation is not stable. Maybe within, if we carry on or continue drilling with this mud weight, we are going to get a kick and we are going to make a blowout. If we make a blowout, it's difficult for us to manage it or to control it. Now, the most important to work as a well site geologist, it's how to interpret. Now you have a good idea how the gas enter to the formation, how the gas chromatograph based on the boiling point and the molecular weight, the chromatograph analyzes those gas mixture. Now, the main job for you as a well site geologist to know how you can deal or how the gas while drilling interpreted. We have two steps for interpretation. First step, it will be collect gas data versus depth and gas data quality control. Guys, in this slide, we can share this slide with you. And I will give a real example. Please, guys, if there is a time, if you have a time or time, you can just make a practice with the formula question I'm going to talking about them. This is the first step, because we have two steps on gas while drilling interpretation. First step, we have to collect the data. Data will be collected to software. That software is dependent on the companies, like a petrol service company has her special software, Beaker, Schlumberger, whatever else. The second thing is the gas data quality. This is just only example. You see here how the data collected. It's normally collected in Excel sheet. Depth versus the gas chromatograph reading. Depth and total gas, C1 methane, C2 ethane, C3 propane, isobutane, and so on. Usually, gas sample will be taking every 50 centimeter, 50 centimeter, or 0.5 meter, half meter. This is just only demonstrate how the gas collected is normal with Excel sheet versus the depth. The second thing, quality control of gas data. When you work with as a well site geologist, you have to take care about that. You have to find out if this data can be used. Is this data meaningful? Can be used for the interpretation? Is the mud logging unit data engineer transfer the data correctly for you? Is there is any effect or is there is any defect or there is or your chromatograph is not work properly? So ensure gas data quality is one of the most important steps to achieve meaningful result. It is important to mention that not all the gas data set used in interpretation. So what we have to do first, we have to make a quality control for gas data. How can we do that? This is the principal equation. The principal equation, gas quality ratio G QR equal total gas. This is total gas. This one that will be recorded. That will record by chromatograph. The second column divided by C1. This is C1, the third one, plus 2 multiply C2 plus 3 multiply C3 plus 4 multiply normal C4 plus iso C4 plus 5 multiply NC4 plus iso C4. So just a simple formula, total gas divided by the summation of chromatograph component. So if good gas quality data will have a gas quality ratio between 0.8 and 1.2. So let us assume if we have gas quality ratio more than 1. What does it mean? If we get gas quality ratio less than 0.8, we said, as we said, you know, the good data quality, it will be between 0.8 and 1.2. So what does this mean if we have more than 1.2? What does it mean if we have less than 0.8? So if we see to this charts, you will see the gas quality ratio. If it is between 0.8 and 1.2, good data. This data can be used, the data set of gas can be used for interpretation. So if it is the gas quality ratio more than 1.2, we have two cases. The first case is maybe there is heavier component, maybe there is a present of C6. But how can we sure if there is a C6 or not? I'm a well site geologist. I have already described my sample cutting. If there is organic matter or there is organic matters in the sample, okay, this is a normal case. Sure, gas should be reading more than 1.2. But if there is no organic matters in my sample after I describe the sample under normal microscope. So what's the second option for me? The second option, there is a calibration problem. Data engineer and Madlugger, they didn't do their job properly. You know, you have to push them. There is a calibration problem. There is some defect in the gas chromatograph. We try to find out where is this problem is exactly. Is that due to the team or due to the gas itself? If that due to the gas itself, we have to change it or replace it. If due to the team, we have to make a course or some, you know, some courses for them to show them how they working. Also the same thing. If the gas quality ratio less than 0.8, also it is a calibration problem. Defect in gas reading. So this is the first important thing in our quality control. Let me repeat it. If we are this is formula. This is the formula. Sorry. This is the formula for the gas quality control. Easy. Just no there is no more difficulties. It will be total gas divided by the summation of the chromatograph. And this is a formula. If the result between 0.8 and 1.2, okay, we will go with the interpretation. If it is more than 1.8, so we have to have in our mind two options. Present C6. Let me first okay. Let me check my samples. If there is organic matter in samples, okay, gas chromatograph is reading fine. I don't have a problem with it. If there is no organic material in my samples, no, there is a big problem. There is a calibration problem. This calibration problem we have to find out if there is a defect in gas system or there is a defect in or there is a problem with the teams. The second, this is just only a good example. If you see it to the left, gas quality ratio log at versus depth has been drawn. We see there is 0.8 and there is 1.2. You will see in this part there is some samples outside 1.2, and that means this is a bad quality data. So we have to investigate it to make our interpretation or investigate it from this bad quality data. So we are going to cut off this gas quality data, to cut off this gas data because it will meaningless for our interpretation. But see guys, this some example is a real example. It's in block 10 in Kharir field in Yemen drilling Yemen blocks or Yemen oil Petromasila basin. In the right things, you will see most, or you can see all the data. It's between this range of 0.8 and 1.2, exactly in one. That means the data is good data and can be used with the trust for interpretation. The second step from interpretation, well, that's what we care about. It's interpretation. Other thing, it will be technical. The chromatograph, there will be some guys will be technical to manage with it. But the second part for interpretation is after you make sure the gas quality, the quality control. After the quality control, you will go with your interpretation. Why we are measuring the answer for the question. Where do we measure the gas while drilling? Because now the gas can be used in two cases: for fluid characteristic analysis and for lithology analysis. What we care about the reservoir, we need to know the fluid characteristic of fluid types, and we are going to use for lithology types. For fluid characterization, we are going to make for fluid differentiation. What is this reservoir is a wet gas, or this reservoir is a dry gas, or this reservoir is a light oil? No, it's a heavy oil. It's a water contact. Where is the water oil contact? Also, the gas can be used for fluid contact and transition section, fluid differentiation, and fluid contact and transition section, and also to vertical fluid evaluation. We will discuss this. What does it mean, vertical fluid evaluation? with the good example in our presentation. And the last thing for fluid characterization is about biodegradation. And also we'll explain and how can we calculate them by using biodegradation. For lithology, to determine the cup rock efficiency, because see, if there is no cup rock, there is no reservoir. If there is leaking in cup rock, there is means the reservoir efficiency, there will be enough pressure for reservoir to produce. The second thing is a pore pressure or formation pressure. Formation pressure is also is a very important for us while drilling. Because why? If there is, as we know, the formation, there is three types of formation: normal formation pressure, subnormal formation pressure, and over pressure or over formation pressure. We care about subnormal formation pressure because we need to know where is the exactly will be happen formation loss or mud drilling loss, and we care about over pressure over formation pressure because this is the point where the cake or what fluid formation fluid influx to the surface. Now let us start with the fluid characterization. First thing, fluid differentiation. So formation fluid is usually obtained during well test. As we know, there is no the only solution to get a sample from formation fluid is after the drilling, after the casing, after the perforation, after we did the perforation job, after we did after we do the wireline job. Because why? Or we are going to run a tool. That tool will be this is, for example, drill stem test, and collect sample. That sample will be take to the lab. That lab will be make a pressure, volume, temperature will test, and you know it will take by using by it will take more than 1 month until we get our result for the fluid type of fluid characterization. More than 1 month, you know, just to take sample, send it to lab, get the result. Just imagine now mud gas information collect while drilling to obtain can be used as a trustworthy tool to determine the fluid characterization. There is no need to wait for 1 month till the sample sent to the lab and get your PPT result. No, it will be simultaneously. Gas while drilling, I have more than 14 years experience. Believe me, guys, you know it's a trustworthy tools and faster tools. You know, simultaneously tools can be used for the fluid characterization. How? This is the question. How can we do that? There is many methods. We'll talk about 4 methods for gas characterization. The first method, it's called gas ratio method. Gas ratio method subdivided to 3 types: witness method, balance, and character. We'll talk about them. Gas ratio method is a combination of three ratio. The 3 ratio result can be plotted together to suggest fluid character. And we are going to see the example. We are going to see the real example. Guys, also I'm going to explain about software. There is software. I have a software. I can share it with you. You know, to use it as for gas interpretation. So, and after we get the 3 ratio, we are going to plot it first depth in semi-logarithmic grid. This ratio is a witness. First of all, a witness will increase with the increase both gas and oil densities. When the gas and oil densities will increase, the witness ratio will increase. What's the witness ratio? Witness ratio, if you focus or see to this formula, this is, you are going to calculate it. It's easy formula. C2 ethane plus propan plus C4 plus C5 C. If you see this C4 means iso plus normal. Iso IC4 plus NC4. C5 here in the equation means IC5 plus NC5 divided by C1 plus C2 plus C3 plus C4 plus C5 multiply by 100. See, there is the second, there is, if you see here, if the witness less than 0.5, no productive zone. If the witness between 0.5 and 17.5, gas productive zone. If the witness between 70.5 and 40, it's oil productive zone. If more than 40, low gravity or residual oil, bitumen, you know, it will be like tar. Now, this is the witness. What we need exactly to know the witness for equation. Now we will go into the balance ratio, balance equation or balance ratio. The balance ratio is also the same direct for the light heavy oil hydrocarbon, used together with the witness ratio. See, balance is completely inversely to the witness. When the witness increase, balance will be decrease. When the balance increase, witness will be decrease. Because as the fluid density increase. Now, how can I calculate the balance ratio? Is C1 plus C2 divided by C3 plus C4 C4 plus IC5 plus and so on, something like, you know, but focus here. C4 is mean iso plus normal. The second thing is a character ratio. The character ratio, this is, it will be, it cannot use with the witness imbalance. It can use alone, but what's the main purpose of this character ratio? To confirm whether a gas prediction is indeed a gas zone or whether a gas is associated with oil. By using this, now we have gas reservoir. Okay, now there is a gas from witness imbalance. They indicate there is a gas, but if this gas predict as a gas zone, as a gas reservoir, or whether as a gas associated with the oil, character can be recognized. That character can be tell you if this is gas associated with the oil or gas zone. See, what's the formula for character ratio? C4 means iso plus normal plus C5 iso plus normal divided by C3. C3, C1 methane, C2 ethane, C3 propane, and isobutane, isobentane, like this. If the character less than 0.5 from your calculation, that's mean what? That's mean you are going the present formation or the reservoir pairing. It will be gas reservoir phase or gas reservoir pairing. If the character more than 0.5 in your calculation, that's mean the presence or the existed formation will be, it will be a productive liquid phase or oil pairing formation. See, this is the very important thing. When you get the result, because spontaneously you are getting the result, you are getting the result from the witness imbalance. When you're getting the result, because you're recording every 0.5, so it will be continuously reading. When you're getting your result, you are going to what? Your result, you are going to show your result as a relationship between the witness balance versus depth. If you see this curve, the blue one, it is a balance ratio calculation that the computed by the formula, by the balance formula. If you see this red curve, it will witness computed by witness ratio or computed by that formula. And this, the green one, it is about the character. See, now let us, from this green one, let us focus for the blue and red. See, the scale from 1, it's semi-chromatograph, semi-logarithmic grade. Scale from 1 till 100. This is the witness imbalance range. And in y-axis, this is the y-axis. In x-axis, it will be the depth. Now, when the witness, we said in the witness increase, and the balance when with the witness curve decrease gradually, and the balance increase. If you see this is a big separation, you will see there in this point around 3000 3035 feet or meters, you will see this, the behavior or trend will change for both of them, for the witness and balance. What does it that mean? This is mean the black lines is mean this is a contact. Contact for what? This is the behavior. See the behavior for the free light dry gas. There will be a big separation between the balance and witness. Also now, if the balance and witness start come together, see there? Now yes, this is a fluid behavior change completely. It will be light gases. This is a free dry gases. This will be wet gases. Okay, when the witness and balance make a cross plot, or they call it positive cross plot. Now they separated like this. They separated like this, and they at some point they cross. See where they crossed here? At this point, they make this cross at this point. This point where they are crossed is a gas oil contact. See, we have now dry, wet oil contact, dry, wet gas contact. Now we have oil gas contact. Now when they cross, that means this is the oil bearing zone. Before it, there is no cross. It will be gas bearing zone. Oh, in oil we have two type of reservoir. We have light oil and we have high gravity oil reservoir. In light oil or light oil reservoir, you will see there is, you know, they will cross, but they will stay close to each other, the witness and balance. But when the separation increase between them, when the balance decrease and the witness increase, this is an indicator for the high gravity oil between this black line and this black line. If the increasing, if the separation increase more than this, that means it's water zone, and this is the oil water contact. See guys, this is what the gas ratio method can be explained. The second thing is about log diagram method. Log diagram method, guys, is a chart show relationship. This is the second method. The first method, you know, but what we have to do while interpretation, we are going to use more than 2 or 3 methods to make our interpretation reasonable. Log diagram method, easy. It's just only chart show relationship between the C1 divided C2, C2 divided C1 multiplied by 10 to the power 3 in y-axis, versus the C3 divided C1 multiplied by 10 power 3 in y-axis. This chart will be available. The zones will be divided. The zones divided based on what? Based on production and gas data, and also based on drill stream test. Zone 1, if your points, most of your reading after you calculate this gas ratio used, it is fall in the zone 1. That's mean dry gas. In zone 2, that's mean gas with condensate. In zone 3, gas with oil. In zone 4, it will be start, you know, bitumen or tars. That the rectangular, this is another method, the log diagram. This is call it a rectangular or Bixler plot method. The same thing is a chart show relationship between different series, between the C1, C2 divided C2 and C1 divided C3, C1 divided ISO and normal C4, C1 divided ISO and normal C5. there is several rule thumbs in this diagram. See, we are going to plot it, those results based on the production also getting. We are going to draw a line. We are going to plot it, a point here, for example. The second point will be there, and the third point will be there, and we are going to connect it, these points, and our production interpretation will be lines. This line will be used for interpretation. If the line between this line and this line, it will be produce gas. Between this line and this line, it will be produce oil, and so on. Negative slope, if there is a slope negative, this is a positive slope. If there is a negative slope, your linear relationship, it will be indicate for the water zone. The third thing is also by using, this is the third part, is by using the triangular method. The same thing, there is a gas ratio used. This is the formula. This is the formula after you are going, if you remember, in phases, in phases statographic or something, there is a triangular. The triangular will be three parts in the or three apex. It will be three apex in the triangular. Yeah, apex in the triangular. This apex means C2 divided C1 chromatograph summation. This apex of the triangular will be C4 divided by chromatograph summation. This apex will be C4 C3 divided by chromatograph summation. And as you know, this is 100%, this is 0%. When you find out where your points will be, then you are going to draw a triangle. The triangle, if the apex of triangle up, that's mean gas bearing zone. If the apex of triangle downward, that's mean oil bearing zone. If the triangle is big, that's mean dry gas. If the triangle is small, that's mean wet gas up. If the apex up, and if the triangle down and it's big, it will low, it will tar or bitumen. If it is small, it will light oil. This is heavy oil, light oil, and this is based on our interpretation for triangle method. Now the second part from our interpretation, now we by using gas, we determine the fluid differentiation. Now we differentiate between fluid. We found out also a fluid contact and transition zone. Now let us talk about by using many methods. The first method is by using gas ratio method. Second method by using log-log diagram method. Third method by using triangular plot method. Now what's mean vertical fluid evaluation? Vertical fluid evaluation, if you see in the left side, there is no vertical fluid evaluation. That's mean you have one fluid inside the formation. You have gas bearing zone. You have gas reservoir. There is no oil reservoir. You have oil there without gas. By using C1, by drawing C1 versus depth, it will show you how the vertical fluid evaluation. If it is like this, street points comes together at the same trend, that means there is no apparent fluid evaluation. There is just only one fluid inside the reservoir. If the C1 show you like this, gradually increase or gradually decrease, also in the opposite side, there is a vertical fluid evaluation. That means you have two phase inside formation, maybe three phase. You have water, gas, and oil. If the trend the same, just only we have one phase inside, it will be one phase reservoir. Also, as we say before, can be used to determine the oil-water contact, gas-oil contact, and because why? If there is a sharp change in our ratio, fluid followed by stabilization at the significant different value, general mean the present of possible fluid contact. This is example. If we see here, this is top of our reservoir. See this trend. This is a sharp change between the gas and this is total gas. You see this is sharp change. Okay, this is gas oil contact. In this part also decrease the gas, and this is a sharp change. This is oil water contact. The same thing for the C1 divided for total gas or for the C1 divided submission chromatograph. The last thing is a biodegradation. Biodegradation means is the breakdown of the organic matter by microorganisms such as bacteria. What is the purpose of biodegradation in oil reservoir? Because biodegradation is very important to predict of oil quality. As a biodegradation increase, the oil quality will be decreased and the oil productivity will be decreased as well, and IBI for gravity will be decreased. How can we calculate use gas system to indicate the biodegradation? By using C1, by using C5, normal and iso C5. Divided normal iso C5, divided normal C5. If the result more than 1, this reservoir will be biodegraded. It predict bad oil quality. If less than 1, no biodegradation, no activities for bacteria, for organic materials. This is example. See, this is real example. If you see a reservoir, the biodegradation value, the result of computed ISO 5 divided normal Z5 is more than 1. That's mean the example is biodegraded oil bearing reservoir, and the oil quality will be bad. Lithology is back, the second part. This is for fluid characteristic. Lithology is back. Lithology is back. The size of gas shoe can directly relate it to rock permeability and porosity. Break in gas condition, change in evaluation can be related to lithology change. What's the main formula or equation can be used for a lithology indicator? This is the formula C1 divided submission chromatograph phases depth can be plotted. Total gas submission chromatograph phase depth can be plotted. C4 plus C5 divided C1 plus C2 phase chromatograph phase depth can be collected, and so on. Now, let us see example. You see, this is Upper Bayad limestone. This is limestone formation, and this is Upper Bayad sandstone. And this is gas chromatograph reading. The black one is a total gas. The red one is a C1 methane, and so on, methane, ethane, propan. Now we see methane here. There is a, first of all, there is a complete change in total gas at this point. That's mean what? This is a reservoir change, lithology change. And if we see here also, if you focus in C1, it's increased, it's more than C2 and C3. But inside this formation, in sandstone formation, you will see the C1 decrease and becomes C5, IC5, and normal C5 more than C1. So gas can be indicator as a lithology change. Gas can be indicator to recognize the type of lithology. Cap-rock efficiency also, this is the last one in lithology and pretty important thing, because if there is no cap, as we said, there is no oil reservoir. I remember I was working in Yemen, there was, we have the same extended for the formation, for the reservoir, in the same block. That block it's called block 10, but we divided that block to 2 compartments or 2 fields, Kharir field and Ato field. In Kharir field, we produce oil. In Ato field, in the same formation, we didn't produce that oil. Because why? There was no cabrock. There is a cabrock, but that cabrock has been fractured, or it's fractured to cabrock. So what happened for the oil there? Seepage and, escape and leaking. So cabrock efficiency estimated for the evaluation of gas combination. What's the main formula can be used? C1 divided summation chromatograph. When I say summation chromatograph, C1 plus C2 plus C3 plus C4 plus C5, and C1 percentage, because the gas system will record the gas component by using ppm, part per million, and when you convert it to the percentage, you have to multiply them by 10,000. Yes, 10,000. By using these two formulas, you computed this two percentage, or to this, the result computed will be computed from these two formulas against depth. You will see how the Cabrook work effectively. Now let us see this example. So there is also no apparent fluid evaluation in this reservoir, but if we see this, there is the gas is sharp change, as we see here. See the gas, if we see here, this is a gas sharply change. That means that effective Cabrook. If there is a sharp change for gas chromatograph, this is effective Cabrook. But see how is the gas working here? It's increasing gradually, or decreasing gradually from top to bottom. See in front of the Cabrook, there is also contamination. The gas, it's look like there is a seepage. There is a leaking from the reservoir to the Cabrook. So it is very important to determine the efficiency. The last thing is the bore pressure. Determine the formation pressure. What's the maximum pressure for the formation? Because we need the bore pressure to calculate our hydrostatic pressure. Because we need that bore pressure to determine our mud weight. What's that formula? Bore pressure or formation pressure equal mud weight minus 420 multiply for background. As we defined before, background, it is the maximum gas, it's the gas reading in front of the reservoir, divided connection gas. CG is a connection gas. As we talk about that, what's the connection mentioned before, what the connection is, and divided of 0.052 multiply TPD. Also, this is what does it mean background BG, and you can use this formula also for calculation bore pressure and determine the bore pressure by using gas well drilling. See guys, this is software. I will show you the demonstration for software if you can see. This is gas evaluation software. We can share that. See, if you see, this is the software. In the software, there is intake analysis. Intake analysis, as we see, character analysis, witness balance ratio analysis, and the type of fluid. Do you see, guys? Can you confirm that? Is that clear in the screen?
Sir, the PPT is still visible. We can't see the software.
Okay, just wait.
Sir, maybe you can share the whole screen, not just the presentation.
Yeah, how can I do that full screen? Like this?
Sir, try to share again and then select screen 1. That is your desktop,
Okay,
not
okay.
just the presentation.
Yes, exactly, sure. Desktop. No, screen. Desktop, yeah. Now, guys.
Yes, sir. Now we can see your screen.
Okay, that's good. See, let me cross this. We'll start again. This is gas evaluation. What we were talking about, all this thing, all this formula, it will be done automatically by software. But if we only use the software, you know, IT guys or telecom guys can use this software, you know, but he doesn't know what does that mean. So what we need to know the basic, how the software is working, because we are specialists. This is our field. Now, let us start. If you see this intake analysis, this is like that diagram I show you, the witness balance ratio versus depth, and the character ratio. And this is the third column, will be dry gas, it will, and if you focus here in the blue box, you will be signed with the type of fluid. The second thing is gas ratio, as we see, Bixler method and triangular method. So now let us start. Now I collect the data. Data has been collected in Excel format, in Excel sheet. Okay, in Excel sheet. That Excel sheet will be transferred to, it will be importing by like this, running, open file. I'm going to bring the gas data. It's Excel sheet. See this, guys? Excel sheet, normal Excel sheet. That Excel is a column. Depth column, total gas column, methane column, ethane column, propane column, and so on. But the format, it will be CSV format. I will print it. I will upload it. Yeah, let me show take it. Yes. See guys, now after I upload it, I will start run my software. I will push this button. If you see guys, depth, hair depth, C1, C2, C4. If you see the result, witness 48.1, balance 1.5, character 1.2. What's the type of the fluid? Residual oil. If we see for this screen, see guys, this is screen, sorry, this one, gas ratio analysis. By using Bixler, see this line have been plotted. It is residual oil or oil zone. This triangular, if you see this triangular, is upward or downward? Apex of the triangular, downward. That's mean oil. If the apex of the triangular, this is triangular, this one, is upward, it's will be gas bearing. Okay, it's small triangular or big triangular, big triangular. That's mean tar or residual oil. And if we carry on, see, second sample, residual oil. Third sample, see for the depth, change, it's change. See, also residual oil. No, the fourth sample is oil, not residual oil. Let us see how the behavior is. See, where is it? This line is in oil zone. See, for the triangle, before the triangle it was big. Now the triangle is small. That's mean, yeah, the oil become lighter, more than heavier. I will carry on. Also see the gas witness ratio balance, witness and balance ratio curve is starting down. This is big separation, is dry gas. Now I will carry on with it. Oil, 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 oil. Gas condense, completely change. Also see this gas condense. Now, because witness is 14, balance 0.6, let me check for the gas ratio. Yes, my curve start entering the gas zone. Okay, let me check my triangle. Triangle, my triangle is upward, not downward, it's upward. Also, it's small or big? Yes, it's small. It's small. That means it's gas or wet gas, condensation gas. Carry on. Okay, now gas. With the result, gas, oil, residual oil, gas condensation, and carry on and so on. If you see, this is the big separation. That's mean water oil contact. This part, it is they make a crossover where for witness the red one and balance the green one. They make crossover here. Okay, this is a crossover. It's oil gas contact. Separation here is not that big deal. So the from gas system, we can conclude that from gas system, yeah, from gas system can be used for evaluation. Excuse me, back. Oh, wait, no, guys. Yeah, upload. Yes. على full screen. More action. Full screen. Now we are going to conclude that this is a conclusion. The last thing, it's about, we're talking about more pressure. Yes, we're talking about gas while drilling software. It's clear from gas while drilling software, guys. Okay. Now conclusion. Conclusion what? The gas while drilling method help wireline team. Now you are a website geologist. See guys, you are now website geologist. Do you know how much does this cost wireline run? At least $1 million. At least. So, for example, why I'm going to waste my money if there is no indicator for oil? Yeah, but how can I identify the oil or reservoir identification? How can I make a reservoir identification? By using a cheapest method, gas while drilling. So wireline, it will be performed after drilling. But guys, while drilling can give me information about reservoir during drilling. So it's a fastest technology. So as a website, before I decided to use wireline job or run wireline tools or not, I have to make I have to look for the gas result, and I have to do gas while drilling interpretation. If there is if the gas interpretation indicate a good indication, that's mean okay, I'm going with the my wireline. The second thing, to help reservoir engineering determine of the perforation and a productive zone. That zone that need to be perforated. Also, as we said, the cheapest and fastest technology can be applied. Assisted drilling operation, because if there is overpressure, if that zone is overpressure, if that formation has a pressure more than hydrostatic, the reservoir fluid will be start in flux, will be start feeding to the power hole, and kick can be happen. That if the kick happened, maybe we are going to lose a lot of things, lose money, lose rig, and also there will be fatality. There will be guys will be died. So it is very important as indicator for overpressure zone. Now, see guys, this work has been done by me. I did this thing. What I did, I took the gas while drilling data in the left side and make interpretation for the gases. And the left side, I took the wireline data and make interpretation for water saturation, oil water saturation, porosity, permeability, and for the fluid contact. What I found that there is a 90%, you can see 98% matching between the gas while drilling data interpretation and wire interpretation or wireline or logging interpretation. So this give us idea the gas while drilling is a good tool, is a trustworthy tool, can be used for interpretation. If there is any question, I'm ready. If there is something specific to clarify, I will be ready to clarify it.
Thank you so much for an amazing session, sir.
Okay.
Now the floor is open for all of you to ask doubts and questions. So if anyone is having one, you can ask her.
Sir?
Yes.
Sir, in the conventional drilling, our mud return path is exposed to the surface, atmosphere. So when the mud comes from the well to the surface, so there is chance to gas come out to the atmosphere. So which can give also a wrong reading. So how can we compensate this effect?
The effect from the atmosphere pressure reduced?
No, sir. In the mud return path, it is exposed to the atmosphere. Am I right? When our mud is coming, so in the flow line, there is chance to gas come out from the mud to the atmosphere before entering to the gas trap or gas chromatography.
Yes, sure. See, there will be affected. If you see for this chart, I will choose this one. See, some gases some gases are going to lose of the free gases, lose or of free gases. So this is just what we need. What in exactly just need a sample, no more than some 0 something centimeter cubic. So if you look to this, there is gas will be released and loses from the gas trap. Will never trapped inside the mud fluid. That's what do you mean?
Okay, sir.
Is there anyone? Just only let me clarify. This is a slide. I will share it with you guys. The three important thing. Try to consider. Focus in the interpretation. Guys, just only please. What we are going just to share. What I did now. What I presented now. What I presented now, guys, is just only this is a practical thing. You will never find it in books or something like this. This is from my experience. This is a training course. I did it. This training course in 2010 with the Total guys, with the Total staff in Malaysia. Gas while drilling is easy, cheapest method technology can be used. You will be expert. You will be like, how can you be like not the other, not conventional, unconventional. To be unconventional, you have to learn something new. So the most thing you have to try to focus in the interpretation. How did this interpretation? Yes, software is going to do this instead of you. There is no need to there is no need just only to do all this formula. But how the software is working? This is our main job. Imagine, just imagine if the software give you a false reading. You need to make a cross check for your reading. So you need to calculate it manually. You need to compute it manually. This is also when you go for the interview with the companies or something like this. What you have to do, they are going to they will be you will be asking about this thing, because this is the main job for well site geologist. Also, not the full site geologist. When you're working as a petrophysics engineer, this is your main job. Sometimes this is will you save your money, because the cost of wireline job is more costly. What we have to do, we have to reduce that cost, especially if there is no indication for chromatograph or for gas. There is no indication for oil bearing or gas bearing zone. Now, easy, just only formula. Gas chromatograph will measure that component from C1 till ISO or normal C5. That component will be transferred to Excel sheet. You will work with that Excel sheet. That Excel sheet, you will put it in software, or you can calculate it by using your compute it by using your hand. That's all. For what? For lithology characteristic, for lithology identification, contact identification, for fluid identification, contact identification, and for separation between the type of reservoir, and also for lithology. If that's cup efficiency, I told you for cup efficiency, this is that happened for me. We have we have the same reservoir in the same area. Imagine in Ahmedabad, we have in the same reservoir sandstone, but in the north part of Ahmedabad, we didn't produce oil. In the south part of Ahmedabad, we produce oil. Why? The same cup rock, the same reservoir properties, the same porosity, the same permeability, the same thing, the same diagnosis, the same green size. Why we didn't produce that from that spot? After many works, I did that works, and after I took more than 15 wells gas analysis, I found out the cup efficiency in the south part of Ahmedabad, it's not work probably. There is a leaking, there is a seepage gas or capillary pressure from the reservoir. It's not in the capillary pressure from the cup rock. It's not efficient to prevent oil from the movement, from the how you call it, from the migration. But in the south part, the gas efficiency or gas cup or cup rock is more efficiency that prevent completely the reservoir that prevent the completely reservoir fluid from the skipping. Last thing, guys, it's about especially thank for our detector, Harvey. RPG sir, our director, many thanks for him. Also for my guides, Andra Bitzer. Also, especially thanks to you guys for giving me your golden times. And it is my pleasure to meet teams like you. Once again, I think also in the future, I'm going to share, participate this my experience or my skills with you guys. I will be ready. Let's this Corona crisis goes, want, and we will start to meet face to face, and we will be happy. It will be my pleasure, just only to share my experience with wireline and gas while dealing with you guys. Thanks a lot.
Okay. Thank you once again, sir, for a great, informative, and a great session. We got to learn so much about the topic in a very short time. On behalf of IADC PDEU student chapter, I would like to thank Mr. Mareb and all the attendees who joined of today's webinar. Now time for a screenshot. So I would like to request all of you to switch on your cameras so that we can take a screenshot.
Just one more thing, guys. Software and this slides will be shared. I don't know exactly how can we share it, but I will send it to you by WhatsApp. Are you okay with that?
Yes, sir, no issue.
Okay.
Okay. So please switch on your camera so that we can take a screenshot.
Sir, if you can stop sharing your screen, we can get a lot more of.
Yeah. I will stop presentation. Yes.
Yes, sir.
Yes, sir.
Yes. Yeah. Guys, sorry if there is some mistake because this is my first time to use Microsoft Team, and forgive me, to take a long time from your precious time. Thank you, guys.
Yes, sir, it was an amazing session. We enjoyed
No,
a
sir,
lot.
it was fantastic. Okay, conclude it, Vedic.
Okay. So did you took the screenshot?
Yes.
Okay.
Yes.
So all those who are interested, so one more thing, all those who are interested to register themselves for the upcoming 3 days workshop on well testing using MS Excel may do the same till midnight. Once again, thanks for joining today's event.
Yeah.
Goodbye and take care.
Goodbye. See you guys.